display first n Fibonacci numbers. Okay, so now you'll say what are that Fibonacci numbers. So in Fibonacci numbers, first two numbers are same, that is 1, and the next number is addition of the previous two. So these are the two numbers, its addition is 2. Then next number is addition of the previous two. Next number is addition of the previous two. Getting? This will go on. Okay, so you can see in Fibonacci series, the first two numbers are 1. Good evening, Sakshi. So in Fibonacci series, the first two numbers are 1 and all the next terms are addition of the previous two. So this 2 addition is 2, then addition of this 2 is 3, addition of this 2 is 5, 3 plus 5 is 8, 5 plus 8 is 13, and going on. So I am telling you, write a pseudo code to display n Fibonacci numbers. N you will accept from user. Okay? So algorithm Fibo. You want to give name to it as Fibo, you can give it. Okay? Shortcut name you want to give. Anyways, how you want, you decide. Right? Now what, okay, first we'll understand the logic first, and then what we'll do, we will write the pseudocode. First I'll just tell you the logic behind it, and then what we'll do, we'll write pseudocode for it. What we'll do is, we'll create 3 variables, means we'll assume 3 variables, A, okay, B, and one more, C. Okay? A, B, and C. 3 variables I'll take. A and B will be initialized with 1. A is initialized with 1, B is initialized with 1. And C is always going to be addition of this 2. That is A and B. Okay? So always in C, what will store? Addition of A and B. So it will be 2. Next, to repeat this process, just what you have to do is, you have to move value of B in A and value of C in B. Okay? First, always move what? B in A and C in B. So if I move B in A, here what will come? 1. And here what will come? 2. Again they are addition. So 1 plus 2 is 3. Okay? Again you will move B to A, okay, and C to B. This will go on. Again their addition is 5. Then B value will come in A, that is 3, here 5, here 8. Again 5 shifted here, 8 is shifted here, 13. And this process will go on. But then you have to stop at some time. Okay? So what you'll do, you'll stop after n times. If you have done this activity n time. But take care that you will always print this A column. See, always keep printing value of A. Can you see? If you print value of A, it is your Fibonacci series only. 1, 1, 2, 3, 5. Is it a Fibonacci series? Yes. So what I said, that is clear to you. You print values of A. Okay? So always take care that you will print value of A. Right? And every time C will be addition of A plus B. A plus B is C. And then you'll copy B in A and C in B. You understanding? Copy B in A and C in B. Again take addition of it. Okay? Done. Then again B in A, C in B. Right? Again do addition and repeat this whole activity how many times? N time. Right? So last time I gave you different notations, while loop, for loop, any one you can use. Okay? So here I'll create one variable, initialize with 1, one more variable initialized with 1. Then I'll write a for loop for I, okay? And I gave you notation of for loop, sure, no? The for loop syntax I gave you, that is one variable initialized with 1 to n, do. Pseudo convention I had given, just check, had I given the similar syntax for I start to end, and then optional step also I gave you. If anything different, just tell me. The generalized syntax last time I gave you, for counter equal to, I gave value 1 to value 2, do, isn't it? And then here one optional also I gave you, step value, do, okay? So that syntax only I am using it. See, so here I have written for I from 1 till n. So every time I value will be how much? 1, next time 2, next time 3, next time 4. This will be till n. And when I becomes n, the loop will stop. Getting? So this loop will go how much time? N time. Now I told you what to do. Display value of A always. Okay? Then C is going to be addition of A and B. Then I told in A, copy what? B. In B, copy C. That's all. Algorithm over. So we will take addition of A and B, store it in C. Then copy value of B in A first, then copy value of C in B. And then repeat this whole activity. And you know that this whole process will go how much time? N time. Is it right? Okay. Right. But one mistake we did, we didn't accept N over here. We have to accept N also. So I'll write read N. N, if you want, you can pass also as a parameter. So I have just accepted here N. Okay. So example, if suppose this algorithm work, read N, okay, and you have entered N as 5, right? N as 5, then tell me values of I initially will be how much? 1. What is value of A initially? 1. What is value of B initially? 1. Okay? Now I is 1 and the loop will start. Has it exceeded N? Is this 1 greater than 5? Tell me, is this 1 greater than 5? No. Okay? Okay, coming back. So tell me, is this 1 exceeded 5? This loop will go on till I is from 1 till n. The moment it goes more than n, it will stop. So is this 1 more than 5? No. So loop will go on. Okay? So what it is going to print first? Can you tell me? It will print 1. Right? Then what will be C? It will print 1. 1 means A. See, print A. Will it print 1? Yes. Then C is addition of A and B. That is 2. Okay. Then tell me addition of A and B is C. Then B is copied in A. Here 1 will come. Here what will come? C. 2. Okay. And then I will increment. Now I will become how much? 2. Is 2 more than 5? No. So now it will print A. So again it's going to print 1. After printing 1, it will take addition of A and B. So how much is addition of A and B? 3. After that, will it copy B to A? Will it copy C to B? Okay. And after that it will increment I. Now I will become 3. Is 3 more than 5? No. So one more time it will come inside. It will print 2. Right? After printing 2, it will take addition of A and B. That is 5. After that, it will copy B to A. It will copy C to B, right? And after that, it will increment I. It will make it 4. Sorry, it will copy that thing is done. Then it will increment I, that is 4. Is 4 exceeding 5? No. So it will again come inside, print A. What is A? 3. Then it will take addition of this both, that is 8. Then it will copy A to B, that is here 5. Here 8. After copying that, it will increment I. It will make 5. Is 5 yet exceeded 5? No. So one more time it will come inside. It will print A. A is how much? 5. Okay? Then it will add it. It will become 13. Then it will copy this here, 13 here, and then it will increment I and make it 6. But is 6 more than 5? Yes, the loop will stop. Getting? So has it printed first 5 Fibonacci terms, n equal to 5? So has it displayed first 5 terms? Right, all of you? Okay. If possible, can you draw flowchart for this quickly and show me? Let's see if you can draw it. Will be very good. I'll be happy to see the flowchart also. You'll draw it? What say? I'll wait for your solution. If you can draw it. Okay. Flowchart for Fibonacci terms, n Fibonacci term. So first what you'll write? Start. Is it right? Okay. After that, the next step will be, you people should interact. You people should at least type in the chat window or unmute and tell me. Here it will be read n, right? Then some computation work, that is initialization. Can you tell me what will be the initialization work? That is A equal to 1, B equal to 1, and I also equal to 1. Okay? So initializing is also sort of computation. So we have to put it in the square box one. After that, we'll check whether I has become greater than n. Getting? Whether I, because I will vary from 1 till n. So if it has become greater than n, you have to stop. Right? So now tell me, I greater than n. Yes. So we are going to stop the algorithm. That is the logical indication कि here the flow chart is over, to stop. But if suppose I is not greater than n, means it is less than equal to n. So what we'll do? We will print first what? According to the pseudocode, tell me. We are going to print, who will tell me? Fast. A, very good. Will print A. And then some computation work. Okay. What is that computation work? Who will tell me? And after doing that computation, we have to again come back for decision checking. Here. We'll come again back here to check whether I is greater than n. Getting? So again I'll come back and check whether I is greater than n. Now here tell me what computations will do.
We will perform A plus B.
Right. C is equal to A plus B. Very good. Then we will copy
A
B.
or
right, B to A,
A
and then we will
and
copy.
C to B.
Okay, so B equal to C, and last will increment also I by 1. So in the flowchart you have to show na increment, like in a for loop. When I'm showing pseudocode, that's what the speciality of pseudocode is, because pseudocode is more of resembling your program, correct? Whereas your algorithm is more of in English words. So this is more closer towards any C or a Pascal or a Fortran program, but not a program. It is not a true program. You cannot directly run it, but it looks as if it's like a program. Correct? And therefore conversion of pseudocode to program is quite easy. Correct? Because it is more closer to some programming syntaxes. Correct? So one more operation, what? I equal to I plus 1. And after that come back, check whether I has become greater than n. Yes to stop, but no to print A, and again do that activity. Add A plus B, keep in C, copy B to A, copy C to B, increment I. Correct? Okay, so hope this is clear to you guys. Right? Yes or no? Just give me confirmation. Should keep giving me confirmation. Okay? Okay, you got it. You can try it with a while loop also. I told you last time while, repeat until, for loop. For also I told when to use. When the number of iterations, that is the number is fixed. How many times? Means your loop is going for n time. But if your loop is getting repeated till some condition doesn't satisfy, then you'll go for while loop or a repeat until. Clear? Okay, one more I'll give you. Now that you try, let's see whether you'll be able to do or not. Okay. Next is write pseudocode to find sum of digits of a given number. Okay, given positive number. Okay. Here I'll write pseudocode to find sum of digits of given positive number. Okay. Example like, if suppose the given number is 7864. Okay. So the sum of digits should be how much? 25. No? Right? 7 and 8, 15, 15 and 6, 21, 21 and 4, 25. So the answer should come as 25. We should display the answer as 25. Okay? Now here the main concept is finding quotient and remainder. Okay? Quotient part and the remainder part after dividing by 10. Okay? Means the main concept is we have to separate these digits one by one. This digit 4, this digit 6, digit 8, digit 7. As it's a single number, we want to just separate the digits, right? And that is possible only by doing division 10 and mod 10. Mod means remainder 10. You understanding? Like if your n is any number, whatever it is, okay, and suppose if you write n divide 10, so it will give you quotient part. Okay, we are not going to do floating division. You understanding? It is just a integer division. Integer division means once you get a remainder which is less than 10, will stop over there. So when we'll divide 7864 by 10, your quotient is going to be 786. Okay, and if I take n modulo 10, Modulo means remainder operator. So n modulo 10 will return you the remainder. So tell me, if 7864, if I divide by 10, 786 is going to be the quotient and 4 is going to be the remainder. You understanding? 4 will be the remainder. You can check also if you try to divide. Okay? Suppose a very simple example if I take. Okay, suppose I am dividing 38, okay, 38 by 10, suppose, right? So you know that 10, 3, 30, and you get remainder as 8. And is 8 less than 10? 8 is less than 10, so you have to stop here. So therefore always remember, when you are dividing by 10, your possible remainders will be 0 to 9, right? If you are dividing anything by 5, the possible remainders will be 0 to 4. Yes or no? It is not at all possible the remainder is 6, because 6 is again divisible by 5. No? You understanding? So if I divide 38 by 10, the quotient will be 3, remainder will be 8, right? If it is 384, okay, so you will take as 38 na, as a quotient. 38 into 10 is 380, and what will be the remainder? 4, and 4 is less than 10, you have to stop. So that will be your last digit. So the concept first you got it, okay, how to separate the last digit. So how to get last digit? Mod 10. So when you do mod 10, you will get the last digit, and when you div 10, you will get the remaining. Okay, again repeat this process. Now whatever quotient you have got, again if you divide by 10, you will get 78, and mod 10 you will get 6. You understanding? Clear? This will go on. Okay, so the main process is separating the digits. This last digits we have to separate. Okay, so I'll tell you the procedure. You try to convert it into pseudocode. Okay, I hope you will be able to do it, right? See, this is your n. Take remainder r, which is n modulo 10. Okay, and take sum, which is sum plus remainder. Okay, I hope you are understanding. Sum is equal to sum plus r. Initially sum will be 0. Okay, what will be sum? 0. N whatever you give, 7864. Okay, now can you tell me, for the first iteration, what will be 7864 modulo 10? 4. Right? No? 7864 modulo 10 will be how much? 4. Now add that 4 to the previous sum. So what is your previous sum? 0 plus 4 will become 4. Okay? And 7864 div 10, that is the quotient, you put it again in n. Okay? So what will be your n again? 784. Sorry, 786. Okay? Again continue. 786 modulo 10 will be how much? 6. What is previous sum? 4. 4 plus 6 is 10. And what will be your new n? 786 div 10, that is quotient 10. Quotient 10 is 78. Get it? Again, 78 modulo 10 is 8. Then 10 plus 8 is 18. And 78 div 10, what is the quotient? 7. Clear? Now can you tell me what is 7 modulo 10? 7 modulo 10. 7 only. Numerator is less, no? So that numerator which is less, that is only the remainder. ठीक है, 18 plus 7 25. And what is quotient now? 7 div 10. When you are dividing 7 by 10, quotient is 0. Why? Because the numerator is lesser. Always remember, when you divide a by b, integer division, not floating division, integer division, a divided by b, then you will get quotient 0 if a is less than b. And a modulo b if you are doing, so you will get the remainder as a if a is less than b. If your numerator is lesser than denominator, so your numerator only is the remainder. And if the numerator is lesser than denominator and you are doing division, integer division, quotient is 0. Getting? So in this context, what will happen? Tell me. 7, the numerator is lesser. So 7 divided by 10 will become how much? 0. And when your n becomes 0, you will stop the process. You understanding? Okay. So first, is this normal process clear to you? Okay, every time what we have to do, take the remainder modulo 10 and add it in the sum, and take the quotient and put it again in n. So whatever is the quotient after dividing by 10, put it in n. Again modulo 10, the last digit, add in sum, and again take the quotient and put it in n. Clear? So the process, I hope, is clear to you guys. Algorithm sum of digits, suppose I'll write. Okay? Then I'll accept n first, the number, and we'll assume the given number is positive. So read n. Okay? First, you'll initialize sum to 0. I hope you are agreeing with it. Sum is initialized to 0. Then we'll write a while loop in which n, till it doesn't become 0, you repeat the activity. See, while n not equal to 0, do, means the steps you are going to repeat. I gave an example in that also. When n became 0, we stopped. So we have to repeat this activity till n doesn't become what? 0. I hope the condition is clear to you. Till n is not equal to 0, repeat this activity. Okay? First activity, what we'll do, we'll get the last digit. And how we'll get the last digit? N modulo 10. Will it give you the last digit? Yes. Add that last digit in your sum. So sum is equal to sum plus r. So old sum plus r, whatever answer you get, put it again in sum. And what will be your new n? The old n divided by 10. You understanding? Old n divided by 10. Whatever quotient you get, that you put it again in n. So just now I told you, if the number is 7864, so 7864 divided by 10 is how much? 786. If you divide by 10, how much will be the quotient? 786. And 786 mod 10. What will be the remainder? 4. Is it right? So whatever your previous number is, divide by 10 and get the quotient and put it again in n and repeat. Check whether it has become 0. No. So again, that n modulo 10. Remainder, add in sum. Again take division 10. It will keep repeating. Okay? Hope it is clear. For example, read n. You are running the algorithm. Read n. What is n? Whatever you want to give. Clear? 5, 6, 2, 9, 3, 9 I am giving. It's not necessary 4 digit, any digit. Okay? Then sum is initialized to 0. Is your sum 0? Right? This is your n. How much is your n? 5, 6, or you want, you can write n first. N is 5639. Sum, how much is sum initially? 0. Okay, read n, so you have given this number, so that is your n. Sum is initialized to 0. Now it will check this condition. Okay, right? Will it check this condition, n not equal to 0? Yes. So is n not equal to 0? Yes. It will come inside and find r. Can anyone tell me what will be r?
9.
Sure, 5639 modulo 10. So r is 9. Now tell me, is that 9 added to sum? So 0 plus 9 equal to 9. Is that 9? That is r added to sum. So our sum is 0. 0 plus 9 is 9, stored again in sum. And what will be your new n? Can anyone tell me? New n. N equal to n modulo 10. Sorry, n div 10. How much will be your n? 563. 563. Okay? That is your new n. Again come up. Check whether it is 0. Is 563 0? No. Again come inside. Get the remainder of n mod 10. So n is 563. So 563 modulo 10. What is the remainder? 3. It will add it in the sum. 9 plus 3, 12. Now your sum is n. So n plus 3, 9 plus 3 is 12. New sum. Okay? And what is your new n? Can anyone tell me? 563 divided by 10. So what is the new quotient? 56. Okay? Again come up and check whether it is not equal to 0. Yes, it is not equal to 0. And therefore, again, new remainder. 56 modulo 10. 6 is the remainder. Add that to previous sum. You'll get 18. Right? And the new quotient is 5. 56 divided by 10. Quotient is 5. Right? Come up. Is it not equal to 0? Yes. Come inside. 5 modulo 10. 5 modulo 10 is 5 only. I told you just now. 5 modulo 10. Numerator is less. When numerator is less, the numerator only is the remainder. Okay? Add that 5 to 18. You'll get 23. And new quotient is 0. Why? Because your n is 5. So 5 divided by 10. 5 divided by 10, quotient is 0. Numerator less, quotient 0. Numerator less, remainder numerator. Okay? So here we are doing division. So 5 divided by 10, numerator less, therefore quotient 0. And when quotient, that n becomes 0, your loop will stop. And when loop will stop, actually here we forgot to do print sum. That is the sum of digit. You can return also. Means if you want to use this algorithm somewhere else, so you can write inside return also. Okay? Okay. So I hope this algorithm is clear to you guys. Yes or no? Just give me confirmation. Okay. Now one algorithm you people will solve. Let's see. Write an algorithm. Algorithm is pseudocode, and try to draw flowchart also for the same case. I'm sure you'll be able to draw flowchart. Okay. Next, I'm telling you, write pseudocode, okay, to check whether given number is perfect number. ठीक है? So we want to just check whether given number is perfect number. Now what is perfect number? The perfect number means number whose summation of its factors is equal to the given number. Summation of its factors is equal to the given number. Like suppose your number is 6 example. So the factors of 6 are 1. Factors means you know, no? The number from 1 till less than 6. All the numbers from 1 till less than 6 and which are divisible by 6. In this case, in general I am saying who are the factors. So for all I, now if I want to say who are the factors, this is your given number n. So I'll write for all I. Okay? Starting from means greater than equal to 1 and less than n. Okay? From 1 till n and n modulo I is 0. Meaning you'll start from 1 till n. N is exclusive. N is not inclusive. N is exclusive. So from 1 till less than n, that all numbers from 1 till n is divisible by that number. So those I, okay, for which n is divisible by I, that I is a factor. Getting? And summation of that factors is equal to the number. So is 1 a factor of 6? Yes, because 6 is divisible by 1. Is 2 factor of 6? Yes, 2 is divisible by 6. 3 is factor? Yes, 6 is divisible by 3. Is 4 factor? No. Is 5 factor? No. And we have to go till 5 only. Now addition of all this is equal to how much? 6. So therefore 6 is a perfect number. Getting? After 6 I guess 28 is there directly. Right? No? 28. Like who is the first factor of 28? 1. 2. 3 is not a factor. Is 3 a factor? No. 28 is not divisible by 3. Then 4? Yes. 5 is not there. 6 is not there. 7 is there. Then 8, 9, 10, 11, 12, they are not there. Last 14. Afterwards no one is there. Now if you take the total of this, okay, you'll get 28 only. Right? 15 is not divisible, 16 not, 17 not, 27 not. Okay? So from 1 till 14, sorry, from 1 till 27 we have to take, but these are only the numbers which are 28 is divisible by these numbers. Okay? So can you write a algorithm or a pseudocode to check whether the given number is perfect number or not? You can try. Let's see, you people. Done? Okay. Rishabh is saying done. Very good. Then share the pseudocode. Rishabh is saying done. What about others? Okay, Rishabh has sent me the solution. He has written actually a C program only. Anyways. Okay, number is accepted, then sum is 0, is starting from I till n, ठीक है, and n modulo, you have used division operator but it should be modulo operator, ठीक है, print perfect, otherwise write not perfect. Okay, somewhat he's mixed up with Python also. Some part he knows about Python. Doesn't matter. It is not at all wrong. Why? Because pseudocode is not the program, but it looks like a program. It resembles like a program of some language. Okay. So he has tried it. Others, like if you have tried, very good. No, so let's solve. Suppose algorithm perfect check I'll give. ठीक है? We will accept one number n. Then we are going to initialize sum to 0. Then we can start a for loop or a while loop also, doesn't matter. For I from 1 till n minus 1, means we should not take n inclusive. You're getting, no? N should be exclusive. Like if n is 6, so we have to go till 5 only. Okay? So I is equal to 1 to n minus 1, do. What we are going to do, so we will check whether n mod I, means we are going to divide n by I and find its remainder. Modulo means remainder. Okay, and if the remainder comes 0, okay, then we are going to add that I in sum. Sum equal to sum plus I. I hope this part you are understanding. We are dividing that n by I and finding its remainder. And if the remainder comes out to be 0, means that n is divisible by I. You understanding or no? Clear? Suppose n is 6 and 6 modulo I, that is 1 first time. So 6 mod 1 is 0 because 6 is divisible by 1. So the remainder is 0. Is 0 equal to 0? Yes. So it will add that I with sum and store it in sum. Then check for the next number. Next number. Now for whichever I, n is not divisible by that I, suppose. So it will just skip that I, go to the next I. Getting? Now when this whole process is over, you will just check whether that sum is equal to n. Whatever that sum has come. Now actually in sum, what we have added? Only the factors. I is a factor of n. Why? Because n is divisible by I. If n is divisible by I, so I is a factor, we have added it in sum. So only the factors are added. Right? So the addition of the factors come out to be as n. Then we will display print. We can give like this: n is perfect number. Okay? Means you can display such strings also. Okay? And else we have to display n is not perfect number. That's all. Okay? Is it clear to you guys? Yes or no? Like if suppose I've accepted n from user as 6, n is 6 from user, n accepted is 6, sum is 0. Okay? Hope it is clear to you. N example I'm telling, n accepted from user is 6, sum is 0. I will start from 1. ठीक है, I is how much? 1. Now it will come and check, is 6 mod I equal to 0? Yes. 6 mod I. Mod means remainder. So 6 modulo 1 is remainder 0? Yes. So will it add that I in sum? Yes. 0 plus 1, 1. ठीक है, and after that I becomes 2. ठीक है, I automatic incremented by 1, so I becomes 2. Then is 2 equal to 6? We are going till n minus 1, means we'll check whether it has become equal to 6. If it becomes 6, it will stop, means it will repeat till 5, and the moment it becomes 6, it will stop. n minus 1 है ना, ठीक है. Okay, so now again I becomes 2. Come inside one more time. Now 6 modulo 2. Is 6 modulo 2 0? Yes, because 6 is divisible by 2. Okay, so will it add that I with sum? Yes, 1 plus 2, 3. And now I becomes 3. Again check, is 3 equal to 6? No, so one more time. ठीक है, one more time it will come inside. 6 modulo 3. Is 6 modulo 3 remainder 0? Yes, 6 is divisible by 3. Okay, so 3 plus 3 is 6, and now I becomes 4. ठीक है, is 4 exceeding 6? Has 4 become equal to 6? No. So one more time, but one more time it will come inside, but 6 is not divisible by 4. ठीक है, तो this if will be false, it will not come inside, only I will increment, I will become 5. Is 6 divisible by 5? No, it will not come inside, only I will increment, I will become 6. But the moment I become 6, loop will stop, because your loop is going till n minus 1. So now it has become equal to n. So if it becomes equal, it will stop. After loop stop, it will check the sum and n. So is your sum and n same? Yes, therefore it is perfect.